In 6.5, we're going to change our focus a little bit from the angle bisectors and the mid segments and all that to inequalities in one triangle. So we're going to deal with some theorems here, and again, these are things that you want to memorize. But one of them is the triangle longer side theorem. It's kind of a weird name for a triangle, or for a theorem rather. It says that if one side of a triangle is longer than another, then the angle opposite the longer side is larger than the angle opposite the shorter side. Okay, so that's like a lot to take in. It's really not that complex. What this is saying is if you look at this triangle, you have side AC here, okay, which is 10 units long, and you have side AB, which is 12 units long. This theorem says that the angle that's created, notice this is a triangle, and it says that the angle that sits across from the longest side, angle C, is going to be greater than the angle opposite the shorter side, which is 10, right? So angle B is going to be less than angle C. And that's because side AB, the one opposite C, is bigger. So bigger side, bigger angle. Smaller side here, smaller angle. So again, if this one here, if side BC was 13 and this would be the longest side, that would mean that angle A is the largest angle. So the smaller the side, the smaller the angle opposite it. The longer the side, the larger the angle opposite it. Now here is the triangle larger angle theorem. So instead of longer side theorem, it's larger angle theorem. And what this says is that if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So this is almost like a converse, really. But what it's saying is, for example, if I look here, I know that this angle is 30, angle A is 30, and angle C is 60. Since 60 is the bigger angle, then the longer side is AB. So I know that if angle C is greater than angle A, then, okay, side AB is going to be greater than the side opposite the smaller angle, which is side BC. Okay? And again, if I think about this, if I know what I know about triangles, remember that the interior angles add up to 180 degrees. That means this is a 90-degree angle. Now, clearly that doesn't look like a 90-degree angle. So this is kind of really a mess. This picture is not drawn to scale. But if this picture is true, right, angle A is less than angle B, or angle C rather, okay, is less than angle C. Oh, the less than and the angles are weird, right? So if angle A is less than angle C, and angle C is less than angle B, in other words, smallest angle to largest angle, then I know that my sides are going to be, my smallest side is going to be BC. The next little bit bigger is going to be AB, right? And then the longest side is going to be AC, even if my picture doesn't do that justice, okay? Because again, this is not drawn to scale. But that's what this theorem is talking about. Triangle inequality theorem is kind of interesting as well. It basically says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side, okay? So once again, if I use a triangle from before, and again, I'm not worried about the angle measures in this one. Notice everything is talking about lengths, so we're only talking about the sides, okay? And what it says is the sum of length of any two sides. So the first one says BC plus AC. Well, BC plus AC is going to be greater than the third side, which is AB, okay? The second one tells me, the second one says that, let me go here. The second one tells me AB, so this side, plus AC, this side is going to be greater than the third side, which is BC. And the last one I'm doing is telling me again, AB, that's this side here, plus BC, this one here, is going to be greater than AC, which is the third side. And so that's all that's saying. So you take two sides of a triangle, and their sum is always going to be greater than the third side. Okay? So again, this is called the triangle inequality theorem. So let's do some practice problems with all that we just learned. It says, name the largest angle and the smallest angle of the triangle. Okay, well, let's look at it. Again, if I want the largest angle, I'm going to go straight to the longest side. If AB in this triangle is the longest side, it's the largest side, then the angle opposite it is going to be the largest angle. So the largest angle is angle C, because it's opposite the longest side. The smallest angle is going to be opposite the smallest side. And in this triangle, the smallest side is AC, which means angle B is going to be the smallest angle. Okay, so angle A will be in the middle. So again, we keep going. It says name the longest and the shortest side. So now I'm going to use the angles for that. So again, I'm not sure if they want me to do all of them, so I'm going to write them all out. I've got 46 and 105. That adds up to 151. So 180 minus 151 is 29. So angle T is 29 degrees. So now if I want the longest side, I'm going to look for the largest angle, which is the 105. So the longest side is opposite that. The longest side is IT. Okay? And then the shortest side is going to be opposite the smallest angle. The smallest angle is angle T, which is 29. So the opposite side of that, IJ, is going to be the shortest side. So again, you find all three angles first. Find the three, and then make your decisions based on the smallest angle and the largest angle. So here again, we're going to apply some of the things we've learned. They want us to complete the statement with either a less than, an equal to, or either a less than, equal to, or greater than. Okay? So given triangle ABC is a right triangle, I like to visualize by actually drawing a triangle. Angle C is the right angle, so let's say A, B, and C. And it says that angle C is less than, equal to, or greater than angle A. Well, angle C is going to be greater than any of the other two angles because it's the largest angle in the triangle. The next one talks about the measure of angle C, and it says, how does angle C compare with measure of angle A plus angle B? Well, we know that the two acute angles in a right triangle, angle A plus angle B, are always going to add up to 90. Angle C is going to equal the sum of A and B. Okay, because again, 90 plus 90 equals 180. Now, the third one talks about sides, and it talks about how does the length of AC compare with the length of AB. Well, AB, notice, is opposite the 90 degrees. It's the hypotenuse. And you've always heard that the hypotenuse is the longest side. Now you know why. The largest angle in a right triangle is the right angle. And so if angle C is the largest angle, the side opposite it, AB, has to be the longest side. So AC is going to be less than AB. So now again, they talk about the lengths of two sides of a triangle are 8 and 13. So basically you have a triangle, and I don't know if it's a right angle. I guess I shouldn't say that. But let's say we have two sides of the triangle, and one side is 8 units long and one side is 13 units long. Well, if we want to find the length of the third side, let's call it x, okay? We know that that third side is always going to be less than the sum of the other two sides. So I know that x is going to be less than 22, okay? That's easy. But now, what is it going to be greater than, right? The third side, x, is going to be greater than what? Well, there's another part to this rule, and it says that the third side always is going to be, again, less than the sum of the other two sides, but it's always going to be greater than the difference. So 13 minus 8 is 5, and I know that x has to be bigger than 5. So it has to be greater than the difference, but less than the sum. So greater than the difference and less than the sum of the other two sides. And so that's an inequality. I know it has to be in that range. It cannot include 5 or include 22. So when we come to these questions where we say, is it possible for a triangle to have the sides indicated? Well, what we're going to do is I always take, it doesn't matter which one, but I like to take the largest side. And I like to say, well, this, I'm going to call the third side x. And I'm going to say x has to be bigger than the difference of 8 and 6 and smaller than the sum of 8 and 6. Well, 8 minus 6 is 2, and 8 plus 6 is 14. Well, is 10 in this range? Yes. Then yes, this is possible. This is a good triangle. So I go to the next one. Again, I know x has to be, in this case, x is 8, right? It has to be greater than the difference of 4 minus 3 and less than the sum of 4 plus 3. And so we get 1 is less than x, which is less than 7. Is 8 less than 7? No. So this is a no. In other words, that the third side has to be less than 7. 8 is not less than 7, so this is not valid. I'm going to go to the next one. I'll go to this one. I'll start with this 5. So I know, again, that my third side, which is 5, they're asking me if it can be 5. I know that it's got to be less than the sum of 4.1 plus 2.5, and it has to be greater than the difference of 4.1 minus 2.5. Well, when I subtract these, I get 1.6 is less than x, which is less than 6.6. And again, if 5 falls in the middle here, and it does, then 5 is a valid third side. Okay, so that's how we do these problems. We're just going to keep going to the last few. Again, I'm going to grab the 2 here, and I'm going to kind of go here, and I'm going to get x is less than, again, 6 plus 4, or 6 minus 4. So I get 2 is less than x, which is less than 10. And if 2 falls in here, which it does not, so this is a no. Remember, x has to be greater than 2. It cannot be equal to 2. And then the last one, I will move it just right down here, and I'll do x has to be less than 6 plus, oops, not 6 plus 5, 6 plus 6. And it has to be greater than 6 minus 6. So 0 is less than x, which is less than 12. And yes, 5 fits in there perfectly, and that's a yes. And so again, we've had 3 yeses here, and we've had 2 no's. So this cannot be, and this one cannot be. And that's how we solve these problems. Again, this inequality is really important.